Picture, if you will, a lump of rock no larger than a potato. At first glance, it seems ordinary, dull, dark, rough to the touch. But this is no ordinary stone. Inside, it carries a treasure, some of the most valuable metals known to humankind. Now imagine this object not on a hillside or buried beneath a desert, but lying 5,000 meters beneath the surface of the Pacific Ocean, in a realm where sunlight has never penetrated, where the cold cuts deeper than ice, and where the pressure is so immense it could crush a submarine like paper. It is in this abyssal world that scientists discovered something astonishing, something that appeared at first to be just another curiosity of the deep sea, but soon revealed itself to be far more. As the data trickled in, it became undeniable. The laws of nature, as we understood them, were being challenged. And the potential value of what they had found? More than $3 trillion. Governments began to take notice. Billionaires quietly funneled funds into secret expeditions. And the scientists who made the discovery began hinting that they had stumbled onto a force capable of rewriting everything we thought we knew about life on Earth. What they uncovered in the deep, 5,000 meters below, was more than a mineral deposit. It was a hidden system, one that may hold the keys to our past, our future, and even the existence of life beyond our planet. The story begins in a region known as the Clarion-Clipperton Zone, or CCZ, one of the last vast uncharted territories on Earth. Stretching between Hawaii and Mexico, this abyssal plain spans an astonishing 4.5 million square kilometers, larger than the entire European Union. Its seafloor plunges to depths of over 5,500 meters, where the temperature hovers just above freezing, where no ray of sunlight has ever touched, and where the pressure is 500 times greater than at the surface. To explore this place is, in many ways, the closest we can come to visiting another planet without leaving our own world. For decades, mining companies cast greedy eyes upon this region. Scattered across its seabed are countless nodules, rocky formations rich in copper, nickel, cobalt, and manganese, resources essential for modern technology and renewable energy. Billions of dollars worth of metals lie strewn across the ocean floor like pebbles in a desert. Yet in 2021, a team of scientists led by Dr. Andrew Sweetman of the Scottish Association for Marine Science ventured here for a very different reason. They were not chasing wealth, but air, the most essential element of all. The team wanted to understand how oxygen circulates in these extreme environments. In the mud of the deep sea, strange life forms endure against all odds. Microorganisms survive here, clinging to the smallest traces of oxygen that seep slowly downward from the world above. By studying how these organisms use oxygen, scientists hope to gain insight into how life endures in hostile environments and what risks deep-sea mining might pose. To do this, they deployed remarkable robotic laboratories called landers, machines capable of descending alone into the abyss, performing experiments and sending back data. Equipped with benthic chambers, sealed containers that captured mud, seawater, and oxygen sensors, these devices were designed to measure how quickly microbes consumed oxygen. But the ocean had other plans. Instead of showing the expected decline in oxygen, the instruments reported the opposite. Oxygen levels were rising. At first, the team dismissed it as error. Salt water corrodes instruments, pressure bends steel, and the cold plays havoc with electronics. They recalibrated, retested, and deployed new landers at different sites. Yet time and again, the impossible repeated itself. Oxygen was appearing where it should not exist. The realization dawned slowly but undeniably. Something in the darkness was breaking the rules of life as we knew them. For 5 years, the team tested, doubted, and re-examined. They knew one thing for certain: photosynthesis, the only known natural process that produces oxygen, requires sunlight. Yet here, in a place untouched by light, oxygen was somehow forming. It was as if they had discovered fire burning beneath the ocean. Was a mineral reaction releasing the gas? Was there an unknown chemical process at work? Or had they stumbled upon a new form of life, one that could generate oxygen in complete darkness? The implications were staggering. If oxygen could be created in the absence of sunlight, then our understanding of Earth's history and the survival of life in its earliest days might have to be rewritten. It could even reshape the search for life on other worlds, such as Europa or Enceladus, the icy moons of Jupiter and Saturn, where oceans lie hidden beneath frozen shells. If oxygen could form here, in our abyss, perhaps it could form there as well. But the mystery only deepened. As they observed the seafloor, strange patterns began to emerge. The ground was not lifeless mud, but a shifting, self-organizing mosaic. Spirals formed with the precision of nautilus shells. Grids unfolded in near-perfect 90-degree angles, like the blueprints of hidden cities. Tessellations interlocked across the seabed with deliberate care. And more unsettling still, these formations moved. Over hours and days, spirals tightened, ridges stretched, grids expanded. The seabed itself seemed to be alive, reconstructing its own geometry as though guided by some unseen hand. Electromagnetic data revealed that with every shift, subtle fluctuations in the magnetic field pulsed outward, like the slow heartbeat of a sleeping giant. The question was whispered among the crew: were they observing the Earth, or had they become part of its process? The scientists turned back to biology for answers. Microbes, after all, are everywhere, even in the most inhospitable places. Perhaps a new form of microorganism was at work. To test this, the team sterilized chambers with biocides, killing all living matter, then repeated their experiments. If life was responsible, oxygen levels should stabilize. But once again, oxygen rose, slowly, steadily, defiantly. No life remained in the samples, yet something was still exhaling breath into the void. The team ruled out microbes, and with that, the mystery grew even more profound. It was then that a clue arrived from an unlikely source. At a deep-sea mining conference in 2022, a speaker casually referred to polymetallic nodules as batteries in a rock. The phrase caught Dr. Sweetman's attention like a spark in the dark. What if these nodules were not inert after all? What if they were active, their minerals interacting with seawater to produce tiny electrical currents? Testing confirmed the suspicion. The nodules indeed produced faint but measurable electricity. And under pressure, those currents were powerful enough to split water molecules into hydrogen and oxygen. Electrolysis, nature's hidden chemistry experiment, was unfolding quietly on the seabed, a geochemical process creating oxygen in total darkness. In the laboratory aboard their vessel, the team measured a voltage of just 1 volt, small yet enough to drive reactions. In the deep, that steady signal carried vast implications. Even the smallest current, over time, can reshape molecules, transform chemistry, and alter ecosystems. The potato-sized nodules, once dismissed as lumps of metal, were in fact breathing stones, natural batteries exhaling oxygen into the ocean, sustaining unseen life. The consequences ripple outward. For marine biologists, this discovery means deep-sea ecosystems may have oxygen sources previously unknown, changing how we understand survival in extreme habitats.
For planetary scientists, it suggests that ocean worlds beyond Earth might sustain life without sunlight. For geochemists, it demands a reevaluation of Earth's early history, when life first emerged in a world with little oxygen. And for mining companies, it raises a troubling dilemma. The very nodules targeted for extraction may be crucial to the balance of life in the deep. If mining disturbs or removes these stones, what hidden systems might collapse? Could entire ecosystems vanish before we even discover them? The race is now on, not merely to exploit the seabed, but to understand it before it is irreversibly changed. Dr. Sweetman reflected, "This isn't just curiosity. We've uncovered a fundamental Earth process hidden in plain sight. We must understand it before we interfere." His words echo like a warning. Humanity stands at a crossroads, to plunder the deep for resources or to pause and learn from it. For what we found 5,000 meters down is not only valuable metal, but a living reminder of how little we know of our own planet. The discovery of dark oxygen, the creation of breathable air and total absence of light or life is nothing short of revolutionary. It forces us to reconsider not just the origins of life, but its persistence in the harshest environments. It tells us that energy and chemistry can conjure breath where none should exist. It hints that Mars, Europa, or Enceladus may harbor the same secret. And it warns us that in our rush for resources, we may be endangering processes older than our species. Once thought to be a dead desert, the abyss has revealed itself as a vibrant, enigmatic force, a frontier as profound as outer space. At its heart lie small stones, potato-sized and unassuming, yet holding the power to rewrite history. The story of life, it seems, may not begin with sunlight at all. It may begin in darkness, in silence, in the slow exhale of a breathing stone at the bottom of the world.